So here we're going to look at the different types of triangles you need to be able to deal with. So some of them will be familiar, some of them you might not have seen before, but we're going to have a look at the different kinds and some of their kind of notable properties, some of the things that you'll be expected to know as you progress through your maths. Okay, so what is it that's useful about these different types of triangles? Indeed, is there anything useful about them? So first kind we're going to have a look at is going to be the right angle triangle, which is, I think, the most well-known one. It is so named because it has to have a right angle in it. Okay, but other than that, the sides can be any length, and the other two angles can be any size. Okay, so it looks something kind of like that, where the right angle is denoted with the little square. So in our instance here, it's down the bottom left, and we can see there's a little square there, just to mark in where the right angle is. The sides are different lengths, the other two angles are very clearly different, and so that's what makes ourselves a right angle triangle. So if it has a right angle anywhere in it, it becomes a right angle triangle. Next kind is an isosceles triangle, which is always a very difficult one to spell, okay, but quite useful. When we're looking at isosceles triangle, two of the sides are the same length. Okay, and so because two of the sides are the same length, this means two angles also have to be the same. So here we've got an isosceles triangle, and there we've got another one. So we've got a blue one and a kind of lilac-y purple one. So those two lines are two slanty lines, if you like, are the same length, and those two there are the same length. And whenever we want to denote that two lines are the same length, we can put lines through them, like these little yellow lines. So these yellow lines here show that they are the same length, which is why the third side in the triangle doesn't have them, because it's not the same size, so it doesn't get the lines go through it. When we're looking at angles that are the same size, the two then at the bottom become the same. And looking at my purple one, the two then would be at the bottom of that triangle are the same. Okay, essentially what we're doing is we're looking for the one point where our two lines meet. So where do our two lines meet? It's the one that's not the same. Okay, so in my blue triangle, where do the two lines meet? They meet at the very top of the triangle. That angle there is different. So what other two angles are you left with? The two at the bottom. Looking at my purple one, where do my two sides meet? Well, they meet at that bottom right hand corner. So it's the different angle. Where are the other two? They're up the top. An equilateral triangle is not a very common one, okay, because it has such a strict set of rules, because all the sides have to be the same length. Okay, so we've got our equilateral triangle, and it's this equi bit at the start suggests that they are all equal, they're all the same. Okay, because they're all the same, that means the angles all have to be the same, and because they all have to add up to 180 degrees, they all need to be 60 degrees each. So our equilateral triangle, because all the lines are the same, they all get this line through them. Okay, so remember from our isosceles triangles just a minute ago, that line, the kind of green line now, just denotes the same length. And so because all the lines have this green cross through it, they're all the same length. And they've all got the same angle of 60 degrees. Finally, scalene triangle. Okay, that's the most common type of triangle because there is nothing very notable about it. Okay, none of the sides are the same length, and so none of the angles are the same. And so we could have something like that, or we could have something like that. So here, there's nothing we can say about any of those angles, and there's nothing we can say about any of those sides. Okay, so chances are, if you were to draw a triangle freehand right now, it would be one in something like that. It would be classed as a scalene triangle.